You've probably heard of hazard communication and right to know before, but you may not have thought about how it affects you. Did you know that what seems like an ordinary cleanser can actually be toxic, flammable, and explosive? Well, it can. You have the right to know about potentially hazardous materials that you may encounter in your workplace. That's why OSHA's Hazard Communication Standard and similar state laws exist. Their goal is to make sure you have the information, training, and equipment you need to work safely around hazardous materials. Chemical hazard information is communicated to you in three ways: material safety data sheets, container labels, and your facility's written hazard communication program. The Material Safety Data Sheet, or MSDS, is basically a guide for the safe use of a specific chemical. Chemical manufacturers and distributors provide an MSDS for each of the products they sell. Your facility keeps copies of each MSDS on file so that you can refer to them whenever necessary. The Material Safety Data Sheet is the primary source for information about a chemical product. The MSDS lists all of the names the chemical goes by, the company that manufactures it, and any hazardous ingredients that the chemical contains. The MSDS also describes the types of hazards that the chemical may present, first aid procedures for chemical exposures, as well as spill cleanup techniques. To help you work with the chemical safely, the MSDS also tells you how to handle and store the chemical properly, and what exposure controls and personal protective equipment to use to protect yourself. Material safety data sheets can come in different formats, but they all contain the same kinds of important information. Be sure to become familiar with the MSDS before you work with a potentially hazardous material. The few minutes this takes could help prevent serious problems in an emergency. Another place to look for right-to-know information is right on the container label. At a glance, the label will provide the material's name and its potential health, fire, and reactivity hazards. It may also list specific precautions to take or situations to avoid when working with the chemical. If necessary, the label will remind you what personal protective equipment you need to wear when handling the chemical. Like MSDSs, all labels do not present information in the same way. Some labels are written, others use shapes, numbers, or letters as warnings. There are also labels that use symbols or pictures to represent hazards or required personal protective equipment. Regardless of the labeling system your facility uses, be sure to read the label carefully before working with any chemical. And anytime you transfer a chemical to another container, make sure that the secondary container is labeled properly. Another place you can find information on hazardous chemicals is in your facility's Hazard Communication Program. This written plan lists the hazardous materials present in your workplace and other useful information. Before we go any further, there are a few technical terms and phrases you need to understand. The duration of exposure is the period of time you are exposed to a substance. For example, the time between spilling a chemical on your arm and washing it off. This type of spill would be referred to as a short-term exposure. In most cases, a short-term exposure will cause no long-term health problems. However, short-term exposure to some hazards can cause sudden reactions or acute effects, such as a rash or burn. On the other hand, long-term exposure to some hazardous chemicals can cause long-term or chronic health effects. For example, the chronic effect of smoking for many years might be emphysema or even lung cancer. The dose or amount of the substance you're exposed to is also an important factor as far as possible health effects are concerned. The larger the dose, the more serious your reaction may be. Routes of entry are the ways that substances can get into the body. These include skin contact, inhalation, and ingestion. Solids, liquids, and gases can all be absorbed through the skin, but liquids pose the biggest threat because they are most easily absorbed. Inhalation is when you breathe in or inhale a hazardous substance. Dusts, mists, fumes, vapors, and gases can all be inhaled. The third route of entry is ingestion or swallowing. This can happen if you eat food that has been contaminated with a hazardous material, or if you accidentally transfer a material to your mouth or face with your hands. Remember, the effects of exposure depend upon the dose and duration of exposure. If these are low enough, a hazardous material may cause no negative health effects. Agencies such as OSHA and the ACGIH have set limits for how much of each substance you can be exposed to safely. This limit is called either the threshold limit value, TLV, or the permissible exposure limit, PEL. You can find the TLV or PEL of any particular hazardous substance listed on its MSDS. Hazardous chemicals have been divided into groups or classes based on the hazards they present and the safety precautions you need to take. Unlike many other chemicals, toxic substances have the potential to disrupt physical processes, such as breathing, coordination, and other bodily functions. Toxic materials can be found around the house, as well as in the workplace. Many products, such as pesticides, cleaners, solvents, gases, and polymers, are toxic. So are the fumes produced when heating, burning, and welding some metals. Poisons are considered toxic substances. A poison can cause serious illness or death, even in a very small dose. Fortunately, there are very few true poisons, and their use in the workplace is limited. Remember, not all toxic substances are poisonous. Most of them are not very harmful in small amounts. The danger lies in larger doses and longer durations. Corrosives and irritants are another group of chemicals commonly found in many facilities. Corrosives can cause serious, even permanent damage to the parts of the body they come into contact with. Most acids are considered corrosive substances. Sulfuric acid, for instance, is one of the most widely used corrosive chemicals. It can be found in dyes, paints, petroleum processing, and even automobile batteries. Many bases are also corrosive, such as caustic soda. This compound is most commonly used in soaps, detergents, and in water treatment processes. Skin contact with corrosive substances can cause redness, swelling, blisters, and even severe burns. Getting corrosives in your eyes could result in permanent eye damage or blindness. Inhaling or breathing in corrosive chemicals can seriously damage the delicate tissues in your nose, mouth, throat, and lungs. Ingestion or swallowing corrosives is rare in the workplace, but it can result in extreme pain, severe internal injuries, and even death. Irritants are often diluted forms of corrosive substances, such as ammonia, antifreeze, thinners, degreasers, and acids. Other irritants are byproducts generated during combustion, such as nitrogen dioxide found in automobile exhaust. Unlike corrosives, irritants generally cause only minor temporary inflammation or swelling at the point of contact. Flammables and combustibles are another common group of hazardous chemicals. From the gasoline that runs your car to the kerosene used in space heaters, from acetylene used for welding to toluene in paints and adhesives. But which are flammable and which are combustible? And what is the difference? The key to telling whether a chemical is flammable or combustible is its flash point. This is the temperature at which the chemical releases vapors that can ignite and burn. Remember, it's not the flammable or combustible liquid that burns, it's the vapor. Liquids that have a flash point less than 100 degrees Fahrenheit are considered flammable. Gasoline, for example, has a flash point of minus 45 degrees Fahrenheit, which means it's almost always giving off vapors that can burn. To be considered combustible, a liquid must have a flash point between 100 and 200 degrees Fahrenheit. Combustibles, like kerosene, are much easier to control because they usually have to be heated up before they'll produce burnable vapors. Liquid fuels aren't the only flammables and combustibles we have to watch out for. Did you know that smoking near an open can of paint or bottle of rubbing alcohol could cause a fire? These and many other materials can also ignite easily. Flammable gases such as hydrogen, methane, propane, butane, and acetylene come with their own unique set of hazards. These and other gases are usually stored in compressed gas cylinders. The pressure inside these containers is enormous. The rupture of a cylinder or valve can cause a sudden, violent release of that pressure. The container or valve may even become a flying projectile. Another group of hazardous chemicals we need to be aware of are carcinogens and suspected carcinogens. As you may know, these chemicals are often linked to cancer. Normally, the cells in the human body follow a pattern to reproduce and grow. Carcinogens can disrupt this pattern, causing cells to grow abnormally, which is why cancer is often fatal. Although carcinogens can affect nearly all areas of the body, they most frequently target specific organs, such as the lungs, liver, kidneys, and the reproductive system. Unfortunately, there aren't usually any immediate symptoms of exposure to these substances. This is why it is extremely important to know about any carcinogens you may encounter. One carcinogen that has drawn a lot of attention recently is asbestos. At one time, asbestos was used in pipe insulation, floor tiles, and fireproofing materials. Automotive brake and clutch linings also contain asbestos. When inhaled, microscopic asbestos fibers can damage the delicate tissue inside the lungs and eventually cause cancer. Suspected carcinogens are commonly believed to increase your chances of getting cancer, but unlike confirmed carcinogens, no direct link has been established yet. Formaldehyde, PCBs, and carbon tetrachloride are examples of suspected carcinogens. There is more to preventing cancer than simply avoiding exposure to carcinogens. There are risk factors that affect your chances of getting cancer. Smoking, for example, has been proven to increase your chances of getting cancer by tens or even hundreds of times. Quitting is the biggest step a smoker can take towards preventing cancer. Another potential workplace hazard you need to be aware of is radiation. While radiation is not usually associated with chemicals, it can cause serious damage to your body's cells and tissues, much like a carcinogen. This group of hazards includes infrared radiation, ultraviolet or UV radiation, X-rays, gamma rays, and other forms of radiation. If you work around radiation hazards, you will need to take steps to protect yourself. Talk to your supervisor to find out more about any radiation hazards that may exist in your workplace. Hazard communication goes beyond simply exercising your right to know. You need to take the process further and act on what you've learned about the potential hazards of your job. This starts with selecting and using the appropriate personal protective equipment, from goggles and face shields to gloves and acid suits. Respiratory protection is especially important when working around many hazardous materials. There are many different kinds of respirators, and it's vital that you use the right kind for the job. It's also very important to make sure that the respirator fits properly. Storage conditions for hazardous chemicals also require some special consideration, such as proper ventilation in case of fumes, adequate lighting for reading labels, identification of storage locations, strong, stable shelving, safe and easy access to reduce the chances of an accident. Small quantities of flammables or combustibles should be stored in UL-approved cans with spring-loaded caps to contain vapors and prevent spills. Larger quantities of paints, solvents, or other flammables need to be stored in approved flammable materials cabinets. Compressed gas cylinders also have special storage considerations. They must be stored upright with a safety cap in place over the valve. A safety chain or bracket is required to prevent the cylinder from falling over. In exposure situations, you need to act quickly to minimize the damage that a hazardous material can cause. Always know the nearest location of running water, because it's usually your first line of defense against chemical injuries. For small splashes, immerse the affected area in running water for at least 15 minutes. For larger exposures, get to a safety shower as quickly as possible. Remove contaminated clothing and stay in the shower stream for at least 15 minutes. Getting chemicals in your eyes can cause severe damage, so you need to go to an eye wash station immediately. Keep your eyes open and flush them for at least 15 minutes. Inhaling hazardous materials can be dangerous, even deadly. If someone is overcome by fumes, get them out of the area and into some fresh air. Check the container label, or MSDS, to see if they may need immediate medical attention. Swallowing a hazardous substance is extremely dangerous. If this occurs, consult the MSDS immediately. It may be necessary to dilute the chemical with water or milk, or induce vomiting. However, in some cases, vomiting may cause more damage. Seek medical attention after any exposure to a hazardous material, no matter how minor it may seem. Some chemicals have delayed or long-term effects, so be sure to supply medical personnel with a copy of the MSDS. In the event of a leak or a spill of a hazardous chemical, you must act quickly. The first concern is people's health and safety. Tend to injuries immediately. Evacuate the area if necessary, and notify the appropriate personnel. If the spill is of a flammable or combustible substance, you should immediately remove sources of heat or ignition. But don't unplug machinery or equipment. Doing so could cause sparks. If you're going to be involved in cleaning up a hazardous spill, make sure to use the proper PPE and cleanup equipment. Check the MSDS or your company's hazard communication plan. First, you must work to contain the spill and minimize contamination. Create a barrier around the spill with an absorbent material. If your facility has a cleanup kit, use it. In most cases, you'll need to absorb the spill with a neutral material. But spills of some substances require special procedures. For example, you must use non-sparking tools when cleaning up a flammable substance. And it's important to remember that you can't just throw hazardous materials into the trash. Many chemicals are classified as regulated waste and must be removed by licensed disposal companies. Check with your supervisor or your facility's safety manager. OSHA's Hazard Communication Standard and other right-to-know laws are there to get us the information we need. But only you can take the steps necessary to protect yourself from hazardous chemicals.